BF Day proudly presents Mr. M's Math Class.
Hello and welcome to episode 12 of Mr. M's Math Class. Can't believe it's episode 12 already. It's crazy. Really quickly, I wanted to say that there was actually two more winners for the quarantine challenge question that are going to have lunch with me and possibly. And those were Lucia and Lucille. They actually turned it in on time, but I just happened to miss it before I was able to announce the winner. So they are also winners on the challenge of the week question. So nice job. Our agenda today, first thing we're going to do is look at pictures of you guys looking at the last episode. And then some of you turned in some of the bonus extra assignment. And so I'm going to show you some funny pictures of me. So that should hopefully make you laugh. It made me laugh when I saw them. 3, we are going to have a new estimation 180. And this is going to be really interesting. This was made by Molly, 4th grade Molly. And so I'll explain that later. I'm really excited about it. 4, I'm going to share some observations from your work from exploration number 11. Number 5, I'm going to introduce the new math exploration number 12, and we're going to talk about perimeter, area, and something called hexarites. So just be ready for that. 6, I'm going to give you a new coloring sheet and a new batch of Ken-Kens, and then I'll have a goodbye message, and then I'll reveal the answer to the estimation 180 question. And first thing we're going to do is we're going to look at pictures of you guys looking at episode 11. And then also right after that, I'm going to have the funny pictures of me. So just know that there won't be a little in between. It'll just go from you guys to funny pictures of me. Enjoy. All right, thanks again for sending those pictures in. It's not too late if you want to take some new pictures and send them to me and edit them and make them funny. I will do this as long as you send them in. So if you were inspired by some of the ones that you saw and want to do something else, then please send them my way. Next up, we're going to have our new estimation 180. And like I said, it's an interesting one. So this one was given to us by Molly, and she actually made a Lego movie. And she used an app that is able for her to do a stop motion animation. And so the question is, how many animation frames are in her movie titled Harry Eats Dinner? So you're going to think about how many still shots did it take to make that whole movie. So you're going to see the movie, and your question is, how many animation frames are in her movie Harry Eats Dinner? All right, so I'm going to share some observations from the exploration number 11. And it seemed like, for the most part, everybody really understood everything. But there was two questions in particular that really got people confused. And admittedly, the quadrilaterals classifications and hierarchy is really confusing at times. And so I'm going to take some time to explain some of these things to you. I'm hoping that you'll be able to understand. I wanted to give a quick shout out to Aj, and he said that it was okay for me to share this. He actually sent me an email with a question, and we actually talked yesterday over the phone, over Zoom, and I was able to explain some of this quadrilateral hierarchy, and it was really helpful. So if you're ever confused about any of the math that you're doing, please reach out, and I'm more than happy to help you out one-on-one. So I'm going to show you here the screen. So the question that really tricked people was number 6. And it says square is the most specific name for a quadrilateral with 4 right angles and 4 congruent sides. List all the other names for a square. And it says here there are at least 4 of them. So I'm going to go up here, and I actually set this up, so this wasn't on your worksheet, but I wrote down the names of each of the answers and actually put a shape as an example for each one. So square is our most specific name for a parallelogram or kite with 4 right angles and 4 congruent sides. Now, if you were to read the definition of rhombus, it says it's a parallelogram or kite with 4 congruent sides. And if you remember, congruent sides means that they're the same length. So technically, that's also a square, right? It doesn't say that it has to have 4 right angles. The square does, but it doesn't say has to. So a rhombus is also a name for a square. And then look at the definition for rectangle here. It says a parallelogram with 4 right angles. Now, it doesn't say that they have to be the same length. So technically, a square actually is a rectangle as well. But not all rectangles are squares. All squares are rectangles, but it's not the opposite. Kite. This was interesting. It says a quadrilateral with 2 pairs of adjacent sides that are congruent. So here in my example, these 2 sides on top are the same length, and these 2 bottom sides are the same length. So they're adjacent means that they're right next to each other. So these 2 are next to each other, and they're the same length. That's actually true for a square too. So these 2 sides are the same, and these 2 sides are the same. So technically, a square is also a kite, but not all kites are squares. If you can see our example here, not all of these are the same length, and they're not all right angles, so that doesn't work. And then a parallelogram, the definition is a quadrilateral with 2 pairs of parallel sides opposite each other. So my example here, these 2 sides are parallel. They'll never intersect if I kept going with a line. And then these 2 are also parallel, and so they'll never intersect. And if you look at my square here, that's the same definition for a square. Both opposite sides are parallel. So another name for a square is parallelogram. So those are at least 4. And of course, another name for a square is a polygon. It's just a shape, right, with straight angles that's closed. And so it could also be a polygon, and it could also be a quadrilateral because it has 4 sides. So that's 6 names that you can give that. And then I'm gonna go back to number 7. It says, is a rhombus also a kite? Why or why not? And a rhombus, the definition for a rhombus says a parallelogram or kite with 4 congruent sides. So all 4 sides have to be the same length. The definition for a kite says a quadrilateral with 2 pairs of adjacent sides that are congruent. So if 2 pairs are next to each other, they must be the same length. So technically, yes, a kite is a rhombus. A rhombus is a kite. Not all kites are rhombuses. As you can see in my example here, all these sides aren't congruent. They're not all the same. But all rhombuses are kites. So I'm hoping that cleared up some things. Again, please don't hesitate to reach out and ask me questions because I'd be more than happy to help you.
Hi guys. So I figured that I wouldn't do an introduction this time. I think that you guys are used to seeing me teaching this way. So first thing we're going to talk about is area. And area is when you're trying to measure when you're trying to find out the space inside of an object here. And so we're going to pretend, because they're not actually, but we're going to pretend that each one of these squares is an inch. Okay, and so the easy way to find area is to multiply the length times the width. And so here I have the length times the width. And so here I'm going to write that length times width. And again, I want to find the space inside. Now I can do that, and this should look like an array for you. I have 1, 2, 3, 4, 5, 6 inches on this side and 4 inches on this side. So this particular one would be 6 inches times 4 inches. And I could individually count them, but I can just do 6 times 4, which is 24. Now, something that gets tricky for some kids is that they forget what the unit is. Now, the unit in this case is inches squared. You can write it that way. You can write square inches like that, but it has to be squared. Now, if you can think about this, each square, I'm literally trying to figure out how many 1-inch squares are there in total. And so there are 24-inch squares in this space. So that's why the answer has to be squared, because inches is actually would just be a line. That wouldn't apply to this. So the area here is length times width. 6 times 4 is 24. So the area of this square is 24 inches squared. All right, so we just went over area. And the next thing we're going to talk about is perimeter. And I'm going to tell you right now that area and perimeter, 4th, 5th graders mix this up all the time. And so if this happens to you, it is okay, it happens, but be really careful when you're trying to find out area and perimeter. So for perimeter, what I want to find is how long is the outside of this square. So I don't want to find the inside. The perimeter is, I want to find the outside, the line. So it's actually just a single line. So I know that this is 4 inches, 6 inches, 4 inches, 6 inches. And so this would be 4 plus 4 plus 6 plus 6. So again, I'm just trying to find the line that is outside the perimeter outside. So 4 plus 6 is 10, 4 plus 6 is 10. This is 20 inches. And because I said it is just a line outside, I'm not trying to find the inside space. And so the answer is just in inches. It's not squared or anything. So that's how I find the perimeter of this shape. Okay, so I zipped by through that area and perimeter because it's pretty simple, I feel like. And so now we're going to look at something called hexarights. And this is a hexagon which has 6 sides, and it looks like there's 2 different squares or rectangles combined together. So it's a very specific type of hexagon where all of the angles are right angles. And so hexarite, all right angles, and it has 6 sides. 1, 2, 3, 4, 5, 6. Okay. So the shape above is a hexagon because it has 6 sides, but let's call it a hexarite. A hexarite is a hexagon in which sides that touch each other are perpendicular. That is, they meet at right angles. And you can see that in this shape. And so I'm going to show you here some examples that are not hexarites. So here are 2 examples that are not hexarites. Can you see why? And you can talk to the screen if you want. I'm going to give you some moments here to think about that. Why is this one not a hexarite? And why is this one not a hexarite? Again, it's okay if you're talking to the screen. If you have your sibling there with you, you can talk to each other. That's fine. I'll give you another like 10 seconds. This one is not a hexarite because, as you can see in this and in here, those are not perpendicular. They don't make right angles, and so this is therefore not a hexarite. Here, all of these are right angles, but I'm sure you notice there are way too many sides. There are not 6 sides. So this is also not a hexarite. And then lastly, here are examples of 2 hexarites below. And it says find the area and perimeter of the hexarites below. So I have my ruler here, and I'm going to measure it in centimeters. So this one is 4 centimeters. This is 6 centimeters. This is 2 centimeters. And this must be 2 centimeters as well if this bottom is 4. This is 3 centimeters. And again, this is 6, and so this one has to be 3 centimeters. Right. So first thing I'm going to do is find the perimeter. And if you remember, the perimeter is just the outside line in the shape. So I have to do 2 plus 6 plus 4 plus 3 plus 2 plus 3. So I'm going to write that down so I don't forget any numbers. And I'm going to count to make sure that I have 6 numbers here. 1, 2, 3, 4, 5, 6. So I'm good. So then I'm going to add them. And then I like to combine like terms to make 10. So that's 10. And then we have 6 and then another 10. So the perimeter of this shape is 20 centimeters. So that's the perimeter. But it says I have to find the area as well. Now the area is tricky because remember, it's length times width. So there's a couple things you can do here. I can split this rectangle, this hexarite, into 2 rectangles this way, or split it up into this way. I like doing it this way. There is no right or wrong answer here. So I'm going to think, well, what's the length and width of this rectangle up here? Now, it's not 6 because that would be this whole length. It's not here. This is 3 times 2. So 3 times 2 is 6 centimeters squared. So this area of this rectangle up here is 6 centimeters squared. And here, this is 4 times 3, which is 12 centimeters squared. Now combine those together, it's 18 centimeters squared. And that's the area of that bottom shape. Now, I'm going to let you do this one on your own on the worksheet, but I am going to measure it for you so you can see that. This is 8 centimeters. This one is just 1 centimeter. This one is 7 centimeters. It's 4 centimeters. This one is 3 centimeters, and this one is 1 centimeter. So I'm going to let you do that one on your own.
All right, so this exploration is going to be 5 worksheets, like we've been doing the last few times, and it is going to be due next Tuesday, May 5th, by the end of the day. Sorry, actually Monday, May 4th, by the end of the day. So make sure to turn that in so that I can make the video on Tuesday without technical difficulties. And just to show you really quickly what that is going to look like here. So this is the worksheet. So you'll have some area problems, and a little bit more area problems, and then you'll have some area and perimeter problems. So you'll be able to tell which one of these is area or perimeter. And then there's a second part to that. And then finally, some complex hexarites with some even more complicated ones that aren't hexarites either. So you'll find the area and perimeter of all of those. And again, that is due on Monday, May 4th, by the end of the day. So make sure to turn those in. Okay, next up, I'm going to talk about the new coloring sheet. So I know that I usually do a regular sheet without a mural, but I found a mural that I think you guys would be excited about. So before in class, I only had the Gryffindor crest, and it seems like they finally updated it. So there is a Hufflepuff crest now. And so that is going to be looking like this. I'm going to show you what that looks like here. So this is the Hufflepuff crest. So that'll be the coloring mural for this time. And then there is going to be a new batch of Ken-Kens. Again, reminder that you can get the app and do it there, so you don't have to print these out. And then finally, I do want to say goodbye for episode 12. Thank you so much for joining me in this episode. A couple things I want to say is that the quarantine challenge question is due next Tuesday, May 5th at noon. So make sure to turn those in to me, and then I will announce the winners in that episode. And then I want to do another plug for questions. And so if you have any math questions, and you would like to talk to me about any of the worksheets that you're confused about, even if it's a little thing, it's okay. Also, it's okay to struggle with some of these things. Struggling is part of doing math, right? If it's all super easy, then there's no point in you doing it. And so if there's some questions that are confusing, really practice that perseverance. And it's really hard to kind of be there. And parents, also let your kids struggle. It's okay. That's part of learning, right? And so if they're getting frustrated, take a break, take a walk, and then come back. But it's really important for you to kind of push through that difficultness. But I'm always here to help you out. So if you're confused and you can't, you've thought about it for more than 5 minutes, 10 minutes, and you're like, I can't figure this out, please reach out. And thank you for those of you who already have. Here's the episode. Here's the answer to the estimation 180. Again, that was given to us by Molly, which is really unique. Thank you so much. And I'll see you in episode 13.